Hello and welcome. So every Python developer hits this point, right? You've got this awesome script on your computer that does something cool, but how do you turn that little file into a real, professional product that other people can use and rely on? It can feel like you're trying to solve a puzzle box, but don't worry, we're going to walk through how to get all those pieces to click into place.
And let's just dive right in with this. Python dependency management is a dumpster fire. You gotta love the honesty you find on Reddit. But look, as blunt as it sounds, it kind of hits home for a lot of us, doesn't it? It's provocative for sure, but it perfectly frames the problem we're here to solve today. Python is so flexible that if you're not careful, things can get real messy real fast.
So why does it feel that way sometimes? Well, it's pretty simple actually. As your project gets bigger, it starts depending on more and more outside libraries, and suddenly you've got chaos. The real question is, how do we bring some order to that chaos? How do we put out the fire? That's what this is all about. Think of this explainer as your own personal fire extinguisher.
First things first, every single great project needs a solid foundation. You wouldn't build a house on sand, right? For a Python project, this means creating an organized, and this is the most important part, an isolated space to work in, right from the very beginning. This part is absolutely non-negotiable for any serious work.
And the cornerstone of that foundation is the virtual environment. Honestly, the best way to think about it is like a personal, squeaky clean, disposable sandbox built just for your project. It's a completely self-contained little world that keeps your project's specific needs from clashing with anything and everything else on your system. And this slide right here nails why they're so critical. Without one, you're living in what we'll call the global mess. Every package for every project you've ever worked on, all dumped into one big folder. It is a recipe for disaster. But with a virtual environment, you get an isolated sandbox. Each project is neatly quarantined with only the packages it needs. No more version conflicts. It's just clean.
And the best part? Getting started is way easier than it sounds. Python's built-in venv module really just boils down to 4 basic commands. You create the environment, you activate it, which is kind of like stepping inside the sandbox, you install whatever you need, and then you just deactivate it when you're done. That's pretty much the whole rhythm.
Now, beyond the virtual environment, a clean folder structure is like your project's business card. It's the first impression you make. This layout here, which is inspired by the legendary Hitchhiker's Guide to Python, is way more than just for looks. It's a map. It tells any new developer or user exactly where to find everything, from your main code to your tests and documentation. Okay, our foundation is poured and the framework is up. Now it's time to tackle the next big challenge, taming the wild beast that is dependency management. We're talking about all those external libraries and tools that your project needs to actually work.
Which brings us to a really crucial and, let's be honest, often overwhelming question. The landscape of Python tooling is constantly shifting and changing under our feet. So how in the world do you pick the right tool for your project?
Let's break down the modern contenders. For a good while now, Poetry has been a huge favorite. It's a great all-in-one tool. But now we've got UV, a new challenger that is mind-blowingly fast because it's written in Rust. And then, over in the data science world, a tool called Pixie is getting a lot of love because it builds on the Conda ecosystem, which is just fantastic for handling complex, non-Python dependencies.
So where is the community actually landing on all this? Well, this quote, and it's actually from the person who wrote that original dumpster fire post, suggests a consensus might be forming. For most standard Python apps, the pure speed of UV seems to be the future. But if you're in that scientific computing world needing things like GPU libraries, Pixie and its Conda-powered backend are still the reigning champ.
But it's not all excitement and hype about the new tools. This other comment from that same discussion really captures a deep frustration in the community, the feeling of constant churn. Just when everyone gets comfortable with a tool like Poetry, something new comes along. It's this permanent tension between wanting innovation and just wanting some stability for once.
So, you've got your foundation set and your tools picked out. It's time to think about growth. Because projects rarely stay a one-person show for long. The moment a team gets involved, you need to have practices in place so that everybody can collaborate with confidence.
This whole process really starts with a disciplined Git workflow. You create a branch to keep your work safely isolated.
You push your branch regularly to share your progress, and you pull to keep up with what everyone else is doing. And then, the most important part, you open a pull request. This is the critical moment for code review, for discussion, and for making sure only high-quality changes make it into the main codebase.
The next layer of confidence comes from automation. Using tools like Pylint and Flake8 is like having a little robot code reviewer on your shoulder. They automatically enforce a consistent style across the entire project, so you can stop arguing about tabs versus spaces and actually focus on what the code does. It just makes everything more readable for the whole team.
The whole guiding principle behind all of this is a concept called shifting left, and this visual explains it perfectly. The further to the right a bug is found, meaning the closer it gets to your users, the harder and way more expensive it is to fix. The entire goal of these practices is to catch problems as far to the left as possible, ideally right on the developer's own machine.
And that means you need to build a safety net, a multi-layered one. You start with unit tests, which validate the tiniest individual functions of your code. Then you add static code analysis to automatically scan for bad practices. And for web applications, you can even use browser tests to literally automate a web browser to click around and test your features just like a real user would. We're on the home stretch. We've structured our project, we're managing it, we've tested it. Now it's time to automate that final mile, getting our project out of our code repository and into the hands of our users reliably and repeatedly every single time. This is the world of CI/CD, which stands for Continuous Integration and Continuous Deployment. You can think of it as the master engine that automates our entire process. Every single time a developer pushes a change, a pipeline kicks off to build the code, test it, and if everything looks good, deploy it automatically. And in practice, that pipeline is just a series of automated quality gates. First, it installs all the dependencies. Then, it runs the linters to analyze the code. It runs all the different kinds of tests. It might even run security checks. And only after passing every single one of those gates does the code get deployed. This is how you build the confidence to ship updates without fear.
And just like that, we've gone from a single lonely script to a fully automated professional product. But this whole journey leaves us with one final big question, looping all the way back to that debate about tooling. Is this constant evolution a sign of a vibrant, healthy, innovative community? Or is it a sign of a fractured one, forever chasing some perfect tool that might never actually arrive? It's something to think about. Thanks for joining this explainer.